factorization. So this is basically taking all the skill of prime factorization, which isn't very useful, but then using it for stuff that is useful, or at least more useful. We're going to talk about how to find the greatest common factor between a bunch of numbers, how to find the lowest common multiple, how to check if a number is actually a perfect square, and then how to check if something is a perfect cube. Greatest common factor, basically it's like you have two numbers, and you want to know if you looked at all the factors that they have, what would be the biggest one between the two of them that they share. It's not necessarily a prime number. Actually, it almost never is a prime number. So let's look at how to do this. Step one, write all the prime factors for both numbers. That's why we learned to do it. Step two, multiply the common factors together. So let's take 8 and 24. Let's write this out. So for 8, I'm going to do the tree method. So we got 2 and 4, 2 and 2. Okay. So the factors are 2, 2, and 2. And we do the same thing for 24. We got 8 and 3, and then this breaks down into 2 and 4, 2 and 2. So we got 2, 2, 2, and a 3. Now, what we need to do is figure out which ones do they have in common. So I already highlighted it so it's easy to see. There were 3 2's here and 3 2's over here. That 3 is not shared with the 8, is not a common factor. So what we're going to do is we're just going to take these 3 2's and we're going to multiply them together. So it's going to be 2 times 2 times 2 equals 8. So 8 is the greatest common factor between 8 and 24. It's the biggest factor that they both share. Now, some of these you can figure out in your head, like these small numbers are pretty straightforward. When it's stuff like 3 numbers or the numbers start getting a lot bigger, the strategy becomes more useful. So let's try with 3 and just see what happens. So with 30, I'm going to find the factors. So we've got 15 and 2, 5 and 3. For 21, we're going to get 7 and 3, and that's it. And then for 18, we got 6 and times 3, same as 2 times 3. So now, between all 3 numbers, we want to see what do they have in common. So I see there's a 3 here, and here, and here, and that's all they have in common. There's no other factors they all share. So the greatest common factor for these 3 numbers is actually 3. We didn't have to multiply anything together. That's it. That's how you do greatest common factor. I honestly think the hardest part about these is just remembering what the steps are to do these. Actually doing it isn't complicated. So now, lowest common multiple, okay? So this is where we take the prime factors of one number and multiply it by different factors of the other numbers. So you'll see what I mean, but again, we start by finding the prime factors of all the numbers. So if we do 8, it's going to be 2 times 4, which is the same as 2 times 2. So those are the factors, the prime factors of 8. And then for 10, it's going to be 5 times 2, and that's it. So now what we do is we take all the prime factors of one number. Okay, so we have 2 times 2 times 2. So I'm just going to write that down at the bottom. 2 times 2 times 2. Then what you do is multiply it by any different factors. So over here, we already have a 2. It's the same as the 8's 2. So I'm not going to use it. I am going to use the 5 because it's different. So I'm going to say times 5. So when we multiply all these together, we end up getting 40. Okay? That is the lowest common multiple. So basically, it's like if you wrote out all the numbers of 8, so like 8, 16, 24, 32, 40, you wrote all the 10s, 10, 20, 30, 40, you can see this one is the lowest they have in common. This list method is pretty rudimentary. The method that we're learning here is much more effective, especially when you have 3 numbers or you have complicated big numbers, stuff like that. But that's how you do it. We're going to do the exact same step over here. So for 3, the only factor is 3. For 8, we know it's 2 times 2 times 2. And then for 10, we know it's 5 times 2. So I'm going to write this 3 first. I'm going to multiply it. Oh, these 2's are all different. So I'm going to do 2 times 2 times 2. And then I got to do the 5. I'm not going to do this 2 because we already used a 2. So when we multiply all those together, we end up getting 120. which is the lowest common multiple of these three original numbers. Now, with perfect squares and perfect cubes, usually the question is going to be either what is the square root of this number, which you can do on a calculator, but we're going to show a different method, or you can do, you'll be asked, is this a perfect square? And you need to be able to figure it out. So the steps are, again, starting with prime factorization, we write out all the prime factors, and the pattern you're going to notice is that there's always going to be duplicates of the factors in groups of 2, because it's perfect squares, so it's 2. When it's perfect cubes, it's going to be groups of 3, because it's cubes. So if I wrote out 9, 9 is 3 times 3. As you notice, there's a pair of 3's. If we do 16, 16 is 2 times 2 times 2 times 2. And again, you'll notice, even though there's 4 of them, you can think of them as 2 sets of pairs. If we do 64, let's break it down using a tree method so we can see it easily. So let's do 2 and 32. And 32 breaks down 16 and 2, 8 and 2, 2 and 4. Well, so many, 2 and 2. So that's going to be 2 times 2 times 2 times 2 times 2 times 2. Okay, and again, pair, pair, pair. So because they're all pairs, we know it's a perfect square. Now what we need to be able to do as well is write what is the actual square root of these things. So what you do is you find each pair and you take one number from the pair and multiply them together. So for example, in this, there's just the 3, so the square root is 3. Over here, we have 2 pairs, so we have 2 and 2. So we take a 2 from each of them when we say 2 times 2 equals 4. That's the square root of 16. Here we have 3 sets of 2's, so I take 1 from each pair, multiply them together. 2 times 2 times 2 equals 8. 8 is the square root of 64. So this is actually a cool method because if you have perfect squares without a calculator, you can figure out the square root, especially if it's super big. The last one we're going to do is perfect cubes, which works a very similar way. Again, instead of getting pairs like we had before, it's going to be groups of 3. So let's break down 27 so we can see it. Sorry. So I know it's going to be 3 times 9, and that's 3 times 3. So again, 27 is going to be 3 times 3 times 3. And you can see it's a triplicate like we expected. It's a group of 3. If we wanted to find the cube root, we would take one number from this group, which is just 3. That is the cube root of 27. Again, we could do this with bigger numbers. It's the same basic idea. Break it down into prime factorization like we do, and you can tell. So the important thing is that you're going to be asked questions, is this a perfect cube? So let's take a number, I don't know, 60. Okay, and we're going to check, is this a perfect cube? So to do that, we're going to break it down into the prime factors. So let's do 2 and 30, 15 and 2, that's a 15, sorry, and then 5 and 3. So let's look at those factors listed out. 2 times 5 times 3 times 2. Just to highlight them, make them a little easier to see. When we look at these factors, they don't have any 3 repeated. There's a pair of 2's, I guess, but then this 5 and 3 don't match and don't go together. So I can say 60 is not a perfect square, and it's not a perfect cube. It has a square root, but it's some decimal, so we don't care about that for right now. And that's basically it.